Welcome to our presentation on correlation and regression. Today, we'll explore the fascinating world of statistical relationships. We'll cover key topics including correlation, scatter plots, coefficient of correlation, coefficient of determination, and linear regression. Correlation measures the degree of association between two or more variables. It's a statistical tool used to study relationships and is quantified using a correlation coefficient ranging between 1 and 1. There are three possible results of a correlational study: positive correlation, negative correlation, and no correlation. Positive correlation occurs when variables increase or decrease together, while negative correlation happens when one variable increases as the other decreases. Positive correlation is seen when both variables increase or decrease together, like height and weight. Negative correlation occurs when one variable increases as the other decreases, such as the speed of a car and travel time. No correlation means no apparent relationship between variables. Simple correlation involves two variables, while partial multiple correlation considers more than two variables. Linear correlation shows a constant ratio of change, whereas non-linear correlation does not. Correlation can be studied using graphical methods like scatter diagrams and algebraic methods such as Karl Pearson's coefficient of correlation. A scatter diagram is a graphical tool used to identify relationships between variables. Data points are plotted on a Cartesian plane, and a greater scatter indicates a weaker relationship. Scatter plots can show various degrees of correlation, from perfect positive and negative correlations to no correlation at all. Scatter plots offer clear visualization, outlier detection, ease of use, versatility, and the ability to analyze multiple variables. However, scatter plots are limited to two variables. Risk overplotting can be subjective and lack direct numerical measures of correlation. Imagine you are a teacher exploring how study hours affect exam scores. You collect data from 20 students, recording their study hours and exam scores. To create a scatter plot, label the x-axis as study hours and the y-axis as exam score. Plot each student's data point and complete the graph for all 20 students. The coefficient of correlation, developed by Karl Pearson, quantifies the degree of linear association between two variables, ranging from 1 to 1. To calculate Pearson's R, find the mean of both variables, subtract the mean from each data point, multiply these differences, sum the results, and divide by the product of the square roots of the sums of squares. Using the same data, calculate the coefficient of correlation and comment on the observed correlation. First, calculate the means for both study hours and exam scores. Then, find the differences between each data point and its mean, and compute the coefficient of correlation. The coefficient of determination, R squared, measures how well a statistical model predicts an outcome. It indicates the proportion of variance in the dependent variable explained by the independent variable. Regression is a statistical technique used to model and analyze the relationship between a dependent variable and one or more independent variables. It helps estimate the dependent variable based on the values of the independent variables. Regression involves predicting or estimating the likely value of one variable based on the known value of another. It can be equation-based, using an equation derived from bivariate data to make estimations, or it can involve a regression curve, which is the equation and its geometric representation used for predictions. In simple regression analysis, the dependent variable, y, is the variable being predicted or influenced. The independent variable, x, is used for prediction or estimation. The regression line is a line fitted to data points to estimate the relationship between two variables, and the regression equation is defined by the least squares method to find the best fitting line. The simple linear regression model is represented by the equation y equals beta 0 plus beta 1 times x. This model includes constants, intercepts, and coefficients. The formula for the slope and intercept are also provided, which help in defining the regression line. Let's look at an example. We need to find the linear regression equation for the given sets of data. First, we will find the equation, then plot the points, and finally determine the value of y if x equals 9. To find the equation, we calculate the slope and intercept using the given data. The slope is 0.95 and the intercept is 1.5, resulting in the equation y equals 1.5 plus 0.95 times x. Next, we plot the points on a graph. Finally, we use the equation to find the value of y when x is 9, which results in y being 10.05.